Hello and welcome to today's session. In today's session, I'm going to make you familiar with random forest concept. Firstly, let's have a look at what is random forest algorithm. Random forest algorithm is a powerful tree learning technique in machine learning. It works by creating a number of decision trees during the training phase. Each tree is constructed using a random subset of the data set to measure a random subset of features in each partition. This randomness introduces variability among individual trees, reducing the risk of overfitting and improving overall prediction performance. In prediction, the algorithm aggregates the result of all trees either by voting for classification tasks for classification tasks or by averaging for regression tasks. This collaborative decision making process, supported by multiple trees with their insights, provides an example stable and precise results. Random forests are widely used for classification and regression functions, which are known for their ability to handle complex data, reduce overfitting, and provide reliable forecasts in different environments. Next is random forest in AI. Random forest works as follows in the context of AI and machine learning. First is ensemble learning. Random forest is an ensemble method, which means it combines multiple models, decision trees, to produce a final result. The idea is that a group of weak learners, the decision trees, can work together to form a strong learner. In AI, ensemble learning models like random forest can improve the performance of predictions by reducing overfitting, increasing robustness, and offering a more generalized solution. Next is classification and regression tasks. Classification. Random forest is commonly used for classifying data into different categories. For example, it can classify an image either a cat or a dog, or classify a customer as high risk or low risk or based on their past behavior. Regression. It can predict continuous values, such as predicting the price of a house based on features like square footage, location, etc. Interpretability and feature importance. One of the key advantages of random forest in AI is that it can compute the feature importance. This means it helps AI systems understand which features or attributes of the data are the most predictive, which can be useful for improving model transparency and interpretability. Next is handling complex data. Random forests excel at Random forests excel at handling complex, high-dimensional, and noisy data. It's particularly useful in AI systems where data is not perfectly clean or structured. Since random forest doesn't rely heavily on the assumption of the data distribution, it can perform well on a variety of like tasks like image recognition, anomaly detection, etc. Next concept is random forest in AI tasks. Here are a few scenarios where random forests are used in AI domain. First one is AI in healthcare disease prediction. Random forests can be used to predict disease based on a patient's medical data like age, pressure, cholesterol levels, and other factors. Example, predicting whether a patient has diabetes based on medical test results and lifestyle factors. The features could include blood sugar level, BMI, age, and family history of diabetes. Second, AI in natural language processing (NLP) sentiment analysis. Random forests are sometimes used to classify the sentiment of text, positive, negative, or neutral, based on various features extracted from the text, such as the frequency of specific words or the presence of particular phrases. For example, analyzing customer reviews and determining whether they are positive or negative based on word usage, based on word usage and context. Third is AI in finance, credit scoring. Random forests can be used to predict whether a person will default on a loan or what their credit score will be based on historical financial data. For example, using features like income, loan amount, For example, using features like income, loan amount, previous defaults, etc. to predict whether a customer should receive a loan. Fourth is AI in robotics, object recognition. In the field of robotics, random forests can be used to classify objects detected by a robot's sensors. This is especially useful when dealing with visual data from cameras or complex sensor readings. For example, classifying objects in a robot's environment. Example, distinguishing between a cup, a book, and a ball. Next point is, or next concept is, how random forest works in AI, a simplified process. First point is data preparation. AI systems typically begin by preparing data. In the case of random forests, this means collecting a dataset with features, input data, and labels, target or output. For instance, in the case of customer prediction, features might include customer age, usage frequency, customer service interactions, and the label would be whether the customer left or stayed. Next point is training the model. Random forests generate multiple decision trees. Each tree is built from a random subset of data, sampling with replacement. Each decision tree is trained on different parts of the data to create diversity among the trees. The key here is that each tree in the forest has different data points and splits, which reduces overfitting and improves generalization. Next point is making predictions. When making a prediction, each tree in the forest gives a vote for classification or prediction for regression. In classification tasks, the label predicted by the majority of tree becomes the final prediction. In regression, the final output is the average of all the predictions from the individual trees. Next point is handling overfitting. One of the biggest challenges in AI is overfitting, where a model is too complex and captures noise in the data rather than the underlying patterns. Random forest helps reduce overfitting by averaging the predictions of multiple trees. Even if one tree overfits, the others may not, and the final model is more robust. Next point is evaluation and tuning. Once trained, the model is evaluated using metrics such as accuracy, precision, recall, F1 score for classification tasks, and mean squared error for regression tasks. Hyperparameters of the random forest, such as the number of trees, the maximum depth of trees, etc., can be tuned to improve the model's performance. Now, let me demonstrate the implementation of random forest. So, here I have implemented, or in this Python program, I have implemented random forest. So, firstly, let me execute this Python program. So, I am once again executing this particular Python program. So, this Python program has some errors. Let me resolve these errors. So it seems that this code had some issues, or this code requires some modifications. Let me check it. So now I am once again executing this Python program. Let me see if this Python program executes successfully. And as you all can see that the Python program in which I have implemented random forest has been executed successfully. So let me explain this program. Key points in the code. First is data. We have a small data set with the three features: feature 1, feature 2, feature 3, and a categorical data and a categorical target variable label. Second model, we create a random forest classifier model with 100 decision trees. Third point is training and testing. We split the data into training and testing sets and then train the model using the training data. Next point is evaluation. After making predictions on the test data, we evaluate the model's performance using the classification report, which includes precision, recall, F1 score, and accuracy. The next point is AI use cases for random forest. AI in image classification. Random forests can be used for classifying images in computer vision tasks, particularly when you need to extract meaningful features from the images, example edge detection, texture features, and then perform classification. Second point is AI in fraud detection. In financial AI systems, random forest can help detect fraudulent transactions by analyzing patterns in customer transactions. Third point is AI in customer segmentation. AI in customer segmentation. Random forests can help identify customer segments that share similar characteristics, enabling more targeted marketing and personalized recommendations. So, lastly, I would like to conclude by saying that random forest is a powerful machine learning algorithm widely used in AI for classification, regression, and feature importance tasks. It's easy to implement, handles complex data well, and is robust against overfitting. Whether it's predicting customer behavior, detecting fraud, or classifying objects in images, random forest has become an essential tool in AI systems. So that's all for today. Thank you for listening me patiently. I hope everyone must have been familiar with random forest concept. Thank you for listening to me patiently. Let's meet during the next video or during the next session.